Topic 6. Topic 6. Topic 7, question 6C, part 2, and question 7B. At least one of the throw gives a 10. Okay. So the 5 phases of a remainder throw. Okay, so the 5 phases 1 minus 9, 20, 21, 22, 23, 24. 3 phases and mother mark 2, 25. So once the remainder when the number on the red die is divided by the number on the blue die is recorded. Okay, so for the probability, so if I fill in this one, 20 divided by 3 got 2, 20 divided by 5 got 1, 22 divided by 5 got 2, then 23 divided by 2, 1, 20 divided by 3, 24 divided by 2, 0, 0. Okay. The pair of dice are now thrown 3 times. At least one of the throw. This one, okay. This is a good question. Okay, I'll try to do it a few times. Whenever you see the word at least, right? The word at least will tell us that we will need to use the complementary principle. Okay, complementary principle. Okay, so this question, when at least, right? The thing is, it can be first throw gives you 0. It can be 2 throws that give you 0. It can be 3 throws that give you 0. So what I will do is I will take the complementary. So I know that all the probabilities, right, add up to 1. Okay, I know that all the probabilities well. So I will take 1 minus the probability that no throws give a remainder of zeros. Okay, no throws give a remainder of zeros. Okay, so I'm going to do it 3 times. Okay, in one throw, what's the probability that I get remainder of zeros? No throws give a remainder of 0. That means, right, I'm looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. In one throw, it will be 9 out of 15. Right? There's a 9 out of 15 chance that I'm going to get remainder. I'm going to get remainder that is not 0 lah, not 0. Huh? So for 3 throws, right? If I'm going to throw 3 times, then it is power 3, right? So this is what I'm doing here. I take 1 minus the probability that no throws give me a remainder of 0. Okay, so this is what we call the complementary method. It is very, very useful whenever you see the word at least appear in the question. Whenever you see the word appear in the question. So if you calculate this, you're going to get 98 over 125. Okay? Can
Wait, but why is that to the power of 3?
To the power of 3, because the first throw is 9 over 15, right? Then you do the second throw, independent, 9 over 15. Third throw, 9 over 15. So you multiply by itself. So this is first throw, 9 over 15. Second throw, 9 over 15. Third throw, 9 over 15. Okay, so far?
Yes.
Hannah? Afia, have you done question 7?
Mm-hmm.
Already, huh?
Yeah.
Okay, very good. Wait. So you are asking me to go through question 7. Yeah, I blur lah.
7B. Yeah.
7B. So 7B, right? Okay, so question 7B here, I'm supposed to draw a sample of n components. The probability that the outcome is incorrect.
Wait, Mr. Tan, I need the same question 7A also. So can you go through the entire question?
Okay, can. On one condition, you're on camera.
but like got my computer got no camera. Because it's like a PC.
That's the same reason that everybody. Okay.
But mine actual one.
Got no laptop, no camera.
The desktop. But tomorrow onwards I use iPad. So okay.
But RJ told me you Zoom with him, use camera leh.
Where got Zoom?
God, he told me. Don't bluff. Okay, anyway, joking lah. Okay, so a manufacturing company produces a large number of electrical components. K% are defective. So K% it means something like, okay, when I want to calculate the probability is something like K over 100. Okay, so probability can be written as a percentage, as a fraction, or as a decimal. Okay, so just take note now. Probably doesn't mean that it must be fraction or must be decimal. It can also be written as a percentage. Okay, so do note this lah. Okay, on a side note, the probability basically is a number between 0 and 1, right? It can be expressed as a percentage, as a fraction, right? It can also be expressed as a decimal, right? There's no issue with that. So it will mean that there is a K% chance. So it's like a comprehension like that, like a primary school comprehension, defective. That means, right, this is K over 100, all right? So we know that in a branch, right, the probabilities add up to 1. So this will be basically K over 100, and this will be 1 minus K over 100, since they must add up to be equals to 1. Then, if the components are defective and components identified defect are disposed of, if a component is defective, there is a 96% chance that the quick test will correctly identify. So what this means is, if a component is defective, there's a 96% chance that the quick test will correctly identify the components as defective. This means that if the component is defective, they're referring to this part, there is a 96% chance that the quick test will be correct. Okay, which is what you want. So imagine next time, right? Let's say Nivi, you sell products, and maybe next time you run like I don't know, sell like a makeup company. Then you want tests for your products. So you want to make sure that your products, most of them can pass. Otherwise, the customer will refund everything to you. Okay, so you want your products to be certified quality, right? So this is what the quick test is for. Then there's a 0.96 chance, right? Because it's 96. So I'm just writing it as a decimal, right? You can write it as a percentage as well, no issue. Then it will mean that if I know that maybe if this is 0.96, what would this number be?
0.04.
Very good. This will be 0.04, right? So next part, if the component is not defective, there is a 6% chance that the quick test will incorrectly identify it as defective, meaning that if it is not defective, there's a 6% chance that the quick test will incorrectly identify it as defective. So this is what they mean. That means, right, this value is 0.06. Okay, 0.06. That means this number here is 0.94. Okay, since they must add up to 1. So with this, right, we need to find out the value of K. Right? So how do we find the K? The key information is actually over here. So just like a comprehension now, we always try our best to read everything, right? So that we use the information given. It's actually over here, right? It's actually over here. The information is actually over here. There is a 0.941 that the quick test correctly identifies components as defective or not defective. So this means that the chance of the test being correct means it's fulfilling its purpose, right? Is defective, not defective. The test is correct. Okay, so what does it mean, right? Okay, so this means that, okay, I'm saying that if it's defective, right, and the test is correct, right, this is one of my outcomes. The second one is over here. If it's not defective, and the test says that correct, this one is a good product. Okay, so basically here, these two in blue, right, adds up to 0.941. Is that okay? So at route number 1 and route number 2, they add up to 0.941. Is that okay?
Can.
So with that, I'll write down A part 2, a K over 100, which is route number 1, multiply by 0.96, added with 1 minus K over 100. Just be very careful if you're working. Multiply by 0.94, gives you 0.941. Okay. So just going to use calculator to calculate, this part. This one I'm just going to open one by one slowly. So I have something like 0.96K over 100 plus 0.94. This part is just brainless calculation. Just do it like algebra, right? Do it like a boss like that. Okay, 0.941. Then personally, I don't like to deal with fractions, so I multiply all by 100, maybe 0.96K multiplied by 100, 94 minus 0.94K equals to 94.1. So you just solve this equation, you should get K equals to 5. It is a very beautiful number. Can?
Okay.
Okay, so that K will be equals to 5, huh? Okay. Okay, so main thing is just to use the fact. The hint here is to use the part that says 0.941. Okay, so B, I now draw a sample of n components. The n components is drawn, which is screen through, means I'm screening like component 1, component 2, which I'm screening a lot of products, right, through the quick test, right? Then the outcome of the quick test is incorrect for at least one of the component. Right, so remember just now somebody was asking, right, what we see at least, what do we do? The word at least will tell you that you need to use the complementary principle. Okay, so this part need to use the complementary principle for sure. This is the only method. Sorry, not complement. I think complementary. Li complementary I is the one that people give you a complementary. Okay, so E is the means the opposite. So you think, okay, I can take 1. I know that all the probabilities add up to 1. And I consider that if the quick test, if I want to define this, right, I'm incorrect for at least 1. That means what? What does it mean? It means that how about I take 1 minus the probability that all n components are tested correctly. All n components are tested correctly. Means I don't even want to let at least 1 happen. I want to go against this at least 1. So you really talk to yourself when you do these questions. What do I mean by I want to defy this at least 1. Okay, give me at least 1 apple. No, when I say no means what? I don't even want to give you 1. Right? I don't even want to give you 1. Right? At least one of the component is incorrect. No, what does it mean? Not even 1 is incorrect. Everything is wrong. Everything is correct. Okay, everything is right. So when it is all correct, right, I know that for one particular component, the probability of being correct is 0.941. Second component, 0.941. Third component, 0. This is like 0.941 times 0.941 times so many 0.941. Basically, they are all tested correctly. Right? All n components is like basically n number of times. N number of times. So it's just telling me that it is 1 minus 0.941 to the power of n. Okay? Now, B part 2. B part 2. Right? By setting up an inequality in terms of n, I find the least value of n such that the probability that the outcome of the quick test is incorrect for at least one of the component exceeds 0.6. So all they are asking for is to use your part 1 answer, this answer, and I want to know that this value must exceed 0.6. That's all. Damn simple. So this is the part where I'm concerned because I know that there is you all will be thinking like, wow, how come probability got inequality? So this one is very interesting because this question includes both chapters, and that's what math teacher like to set. They like to test you many chapters with little marks, right? That's how cheapskate we are. So from here, 0.941, if you push it to the right, this will be less than 0.4, right? Just we are combining the 1 and the 0.6 together. Now over here, what do we do, right? This is a power n, right? So remember, take log on both sides. I just simply take log, or you want to take ln also can. I just like to take ln because ln is a natural log, and I like to be natural. Okay, so power n, take ln on both sides. By power law, I bring my n in front, and I remember that power law ln 0.4, right? These two values are just take note they are negative. Okay, you must remember that they are negative. So be very sensitive to your numbers. Okay, be very sensitive to your numbers. These two numbers, they are negative because they are less than 1. Okay, can I? So I think in earlier consultations, I also mentioned a lot of times that you ln the value, it is negative. Ln of any number between 1 and 0, it is negative. Okay, in case you are not sure. What does it mean? If I want to make n the subject, this is ln 0.4 over ln 0.941. A lot of people will do this, but unfortunately, it is wrong. Why? Because you must remember, since you are dividing by ln 0.941, the inequality sign change. Okay? Because this is a negative number. So with that, your n will be 15.068. Okay, and that this number of n will actually be equals to 16 since n must be a positive integer. Okay? Okay, sorry, just now who was?
Wait,
F
I have a question. For the part like the second step, why did the signs change?
Why did the signs change? Oh, I mean,
Oh wait, okay.
you understand it? Oh,
Yeah. So whenever there's a ln or log and the number there is like between 0 to 1 is a negative number.
0 to 1 is a negative number, correct? So the idea is because of the graph. So you know log x, right? This is y equals to ln x, okay, like this is the line which is x, then this is the y-axis, right? So you can see if 1 is over here, right? You can see that in this portion, right, when x is between 0 to 1, right, your y value is negative. Can you see? Your y value is negative. Okay.
It applies to both log and ln, right?
Yes, it applies to both log and ln. Or last few days, business not good. Thursday was sad. Thursday got nobody. Thursday only Esther Kim.
I think the nearer it becomes to a quiz, the more people come.
Oh, yeah. It's like, what do they call it? Yeah? Hugging the Buddha's leg.
I need to go because yeah, because I
Okay, no problem. But then Julie, you all are good friends. Ah. How you all know each other? But you all were in different class. Ah.
I
How
hit on her in
Julie,
the hallway.
oh, same CCA, right? Same CCA. Ah.
No, I hit on her in the hallway.
You hit on her in the hallway. Which hallway? Classroom corridor. I mean.
Yeah.
Same CCA lah. Same CCA lah. COG 在 same CCA. Okay. But this girl last time DSA got Zoom interview. I remember I got interview this girl. Wow, I think primary six, her 古筝 grade is don't know what one, like very, very high one.
Xingray.
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 Yeah.
Either Xingray or Trini's.
No, Xingray
No,
higher.
no, it's before it's not your level. It's I think your junior. JH1, JH2.
Luan.
So when they
Joanne Ashley.
or I think I don't know, I don't know the name. But I know the she's so good that the what is it Xu 老师 ah? Is it Xu or
Yeah, Xu 老师.
Yeah.
oh, she also praised him. She also say, wow, sound like one of the best I've heard. But
Joanne.
I don't know whether that girl came in the end. But for it to be so good until even on Zoom it sounds nice. Wow, I think not easy.
Is there no business now?
Business now no business You got any question?
No.
No.
I got a question.
Oh yeah, yeah. Okay, got question